Okay, so now we're going to look at graphing polynomials using our calculator to help us, using some of the other features we know, identifying the end behavior, making tables of values, and finding other key features. Now, a lot of times we might not be able to find exactly some of the key features, but we're still going to look and see if we can. Okay, so for this, the first thing I want you to do, given this polynomial, identify the degree, the leading coefficient, and the end behavior. Pause the video and do that. Unpause when you're ready to discuss. Okay, so hopefully we got that the degree is 3, leading coefficient is -1, end behavior, as x goes to -infinity, f of x is going to go to positive infinity, and as x goes to positive infinity, f of x is going to go to negative infinity. I know that because the degree was odd and the leading coefficient was negative. Okay, now we are going to make a table of values. To do this, I would use my calculator. You can use Desmos as well. That's totally fine. But again, it's good to get used to using your calculator some, just because that's what you're going to need to do on standardized tests. So let's go ahead and pull out our calculators, and we'll go to y equals. Now the equation was -x cubed plus x squared plus 3x minus 3. So I'm going to type that in. So I've got -x cubed plus x squared plus 3x minus 3 plus x squared plus 3x minus 3. Double checking my equation. Looks good. All right, so the table of values, let's just use the table on the calculator. So I do second graph. I see my table. I wanted these values. Now you could use other values as well. I'm going to use these because these are probably going to be the nicest for the graphs that we're going to do at least. So that's why I filled this in for us. But we can pick other x values. So just keep that in mind. You don't have to use those. So I see when x is -2, y is 3. When x is -1, y is -4. So let's start to write those in. I can't memorize all of this. So that was -4, and I already forgot that was 3. So this is 3. When x is 0, we're at -3. I should know that because that's my y-intercept. When x is 1, we're at 0. And when x is 2, we are at -1. Now notice that if I kept going, at 3, we're at -12, at 4, we're at -39. So some of these y coordinates are going to get pretty big pretty quickly. If I went one more in the negative direction, at -3, we're at +24. Now another nice thing on the calculator then, also I would recommend just hitting graph so I know what it's going to look like, right? And we knew the end behavior. Remember, we knew it was up left, down right. And we can see a few of the other features as well. So there's a relative minimum somewhere around here, which is a little bit less than -1. I'm sorry, a little bit more than -1, it looks like. And we know that at 1, there's a x-intercept, but it looks as if there's another x-intercept somewhere here between 1 and 2 as well, because we know at 2 from our table that it was negative again. So if I graph this, let's go ahead and plot these points. So -2, 3, -1, -4, whoops, -1, -4. I know 1, 0, or sorry, 0, -3, and then 1, 0, and then 2, -1. So then if I graph this, my graph will look something like this. Questions? Okay, great. Next one. Same thing. I want you to do the whole thing though. So identify the degree, leading coefficient, and behavior. Find some points, plot the points, draw the graph. Pause the video, unpause when you're ready to check. Okay, so hopefully your graph looks something like this. How did I get that? Degree is 4, leading coefficient's 1. As x goes to -infinity, fx goes to infinity. As x goes to positive infinity, fx also goes to positive infinity. Degree is even, leading coefficient's positive, so it's up, up. I got these values from my calculator, so I put the function into y1. I looked at my table. got those values, and then I checked the graph just to get an idea of what it looked like. So I knew the end behavior, right? And I knew some of the points, but especially here, since it's kind of going up and down a little bit, I knew there was, it looks like a relative minimum somewhere really close to this point, and a relative minimum somewhere really close to this, relative max somewhere right around here. And I knew this one x-intercept, and I know there's another x-intercept here. Next, same thing. Identify the degree, leading coefficient, and behavior. Find some points. Draw your graph. Pause the video. Unpause when you want to discuss. All right, so here, hopefully your graph looks something like this. How do we get that? Good question. Glad you asked. Here we go. Degree is 4, leading coefficient's 4. It's a coincidence they're the same number, but I recognize that the degree is even, leading coefficient's positive. That's what I care about. So my end behavior is infinity, infinity, or up, up. Notice I will just point out, so I'm intentionally using the different color coding because that is a teaching technique, and I am a teacher, and that's what we're doing here. But because I want to point out what I'm doing in purple, that is the thing that doesn't change, right? That's the same every time we write our end behavior. As x goes to negative infinity, f of x goes to, as x goes to positive infinity, f of x goes to blank. And this is what we're actually answering. Here, then I went to my calculator, put the function in, looked at my table, and I saw these values, 48, 0, 0, 0, 48. And this one is really important that I looked at the graph, right? Because I know the end behavior, but since these three values came out to be 0 in my table, I need to see, well, what's going on between them, because it's not just going to be a flat line. That wouldn't make sense. So I don't want to just draw, okay, 0, flat line, and then go up again. So I had to look and see, well, what's going on? And there appears to be a relative minimum kind of between -1 and 0, and a relative minimum between 0 and 1. And it looks as if it's just bouncing right here at 0. So that's how I came up with my graph. So, in conclusion, when we're graphing polynomials, identify the end behavior, so look at the degree and the leading coefficient, make a table of values, use your calculator to help you with that, and then identify other key features if you can, so intercepts, relative minimums and maximums. You're not always going to be able to find all of them, at least not right now, but do the best you can, and then look at the graph on the calculator to help you get the general shape.